All right, here is systems of equations using the substitution method. So we just finished graphing, and you should know from graphing that our answer is an x and y coordinate. So this is just another method to do the same thing. So let's get started. So when you're doing the substitution method, the key word is to substitute, okay? You want to have one of your variables by itself. Now, some problems, the variable will already be by itself, and some problems you may have to solve for it. This one here, we see that y is already solved for. So this is like saying y is 3x. So what's going to happen is I'm going to take this y and I'm going to substitute it in the other equation. So it's kind of like I'm putting one equation inside the other. Okay, so when I write out my first step, I'm going to have 4x plus 2 times 3x equals negative 30. Notice that since I'm plugging something in, I am using parentheses for that 3x. Okay, so that's probably the hardest part in the whole thing is knowing how to substitute it in. Then from there, all you need to do is just solve for x, which we've been doing all year. So I'm going to start with 2 times 3x, that's 6x. I'm going to bring down 4x and bring down the negative 30. Then here I notice I have these like terms, so I have 10x equals negative 30. Then I divide by 10, and my answer is x equals negative 3 for that x. So I can go ahead and write here that x is negative 3. That's an ugly 3, negative 3. Okay, so remember we said that it must be an x and a y. So now that I know what x is, I'm going to take that and I'm going to plug it into one of my equations. Okay, you can choose any equation you want to, and you'll probably notice after doing a few examples that some equations will be easier than the others. Okay, so I'm gonna choose the first equation. So I'm gonna have y equals 3 times negative 3, because remember that's our x. So I'm just gonna plug that in, and 3 times negative 3 is negative 9. So my final answer, which must be written as a coordinate point, is negative 3, 9. Okay. And if we were doing graphing, that would also be our intersection point. All right. Let's look at the next one. So if I was to ask you which variable is already solved for, we have that x is solved for already. So that means I'm going to take this x and plug it in the other equation for x. Okay, so I'm going to just leave some space so you can kind of think about what's happening here, okay, because some people get confused there. So this is like saying x is negative y minus 1. In the other equation, I have 2x minus y equals 7. So since I know that this is x right here, I'm going to just go ahead and plug in my negative y minus 1. Okay. Then from here, I'm going to do my distributive property, and I'm going to solve for y. So I have 2 times negative y, that's negative 2y. 2 times negative 1, negative 2. Bring down negative y and bring down 7. Then from here, I notice I have like terms. So negative 2y minus y will be negative 3y. Minus 2 equals 7. Then I add 2 to both sides. I'll have negative 3y equals 9. Then I divide both sides by negative 3. And I'll have y equals negative 3. Okay. So that's our first part. Okay. Then next, I want to take one of my equations. Like I said, you can choose either one. And I'm going to find my x. So I have x is equal to negative y, which y is now negative 3. So I'm going to put negative 3 in right there. Minus 1. Okay, so we know that these two negatives multiplied, that will give us a positive. So I have positive 3 minus 1. 3 minus 1 is 2, so x equals 2. Then my final answer will be 2, negative 3. Okay, we want to write that as a point. And yeah.